In order to describe motion of an object in 2-dimension plane or 3 dimensions space, we need to use vectors to describe the above mentioned physical quantities. In 2D means plane or 3D means space. Motion we need to describe vectors first. If we have the knowledge of vectors, then we can easily understand the motion of an object in a plane. There are two physical quantities. There are two physical quantities. One is known as scalar quantity, and second one is known as vector quantities. First one is known as scalar quantity, whereas second one is known as vector quantity. Now we shall discuss one by one what is scalar quantity and what is vector quantity. A scalar quantity, scalar quantity, those physical quantities which have only magnitude but have no direction. Those physical quantity which have only magnitude but have no direction. Scalar quantity, those physical quantity which having only magnitude but no directions. For example, speed, distance, work, energy, power, potential, etc. Second one is vector quantity. What is the meaning of vector quantity? Those physical quantity which having both magnitude as well as direction. Those physical quantity which having both magnitude as well as direction is known as vector quantity. For example, displacement, acceleration, force, electric field, etc. Once again, scalar quantity, those physical quantity which having only magnitude but no direction is called scalar quantity. For example, speed, distance, work, energy, power, potential, etc. Number 2, vector quantity, those physical quantity which having both magnitude as well as direction is called vector quantity. For example, displacement, acceleration, force, electric field, etc. Important point to be understand, to keep in mind always, is what note point is I can say कि vector quantity always follows the triangle law of addition and triangle law of addition and parallelogram law of addition. Only vector quantity is that quantity which always follows the triangle law of addition and parallelogram law of addition. Now the point is what? How to denote a vector quantity. How to denote a vector. Answer is if we have a vector, if a vector is equal to v, means having both direction, it has both direction as well as magnitude, means v have both direction as well as magnitude. So v can be written as like that. V on arrow means arrow defines the direction, arrow defines the direction of vector v, whereas v defines the magnitude, Similarly, a vector can be written as a vector, a magnitude, and arrow means direction of the vector a. Position and displacement vector. Position and displacement vector. How it can be seen, how it can be represented. This is our y-axis and this is our x-axis, where two axes are meeting together is called origin point and O. Origin point as O. Let P to P dash, let P to P dash be the positions of the object at time t, and this is the position at time t dash. This is our point. I can mention in it with a different color. This is our point, this is our point. We join O and P. We join O and P and let this distance is R, means from O to P, the vector has the magnitude R, whereas O to P dash, the vector O to P dash has the magnitude R dash. O to P dash is equal to R dash. An arrow is marked at head of this line. It is represented by R at OP and R dash at OP dash. I am taking a different color of pen. If the object moves from P to P dash is called, this distance P to P dash is called what? Displacement vector. This P to P dash is called what? Displacement vector. Displacement vector. This vector is called what? Displacement vector. Let me explain again. This is our y-axis, this is our x-axis. This is our path at point P at time t. The position vector of point P at time t is r, whereas the position vector of P dash at time t dash is r dash. R represents the magnitude of OP, I mean origin to point P at time t, and r dash represents the magnitude of OP dash, I means point P dash from origin at time t dash. Note point, note point, note. We must have to consider, we must have to understand the note point is what? Magnitude of displacement is either less or equal to the path length of an object between 2 points. Means displacement of an object between 2 points is either less than or equal to the path length covered by the object. This path length is also called distance. Distance means displacement is always less than or equal to the distance covered by the object. This equal sign when a particle is moves in on a straight line. When a particle move on a straight line between point A to B, this is a straight line. This is a straight line path. A straight line path. This is a straight line path. This is a straight line path. Then this is our object. This is our object moving towards B from A. Then we can say that the displacement of the object from A to B is equal to AB, whereas distance of the same object on the over the same path is equal to AB. That means on this straight line path, displacement is equal to distance only when the body moves on a straight line. Body moves on a straight line path. One more important point is equality of vector. Equality of vectors. Two vectors vector A and vector B, both are said to be equal if they having same magnitude and having same direction. Two vectors A and B, vectors A and vector B is said to be equal if both having the same magnitude as well as having the same direction. Then we can say that vector A is equal to vector B. Then vector A is equal to vector B. Another point is what? Free vector. Very important topic to understand that. We know that the vector do not have the fixed location. So displacing a vector parallel to itself leaves the vector unchanged. Such a vector are called free vectors. Displacing a vector parallel to itself leaves a vector leaves a vector unchanged, such vector is called what? Free vector. Such vector is called what? Free vector. Free vectors means means when we if if I have a if we have a vector a if we have a vector if a vector is a, if this vector displays parallel to itself, this vector is displaced parallel to itself, this vector is displaced parallel to itself, this vector a is displaced parallel to itself, is always unchanged. This is called what? Free vector. This is called what? Free vector. This is called what? A free vector. Localized vector. Localized vectors. Localized vectors. Point of application. Line of application. Line of application. Line of application of a vector is important, is called what? Such type of vector is called localized vector. Thank you. Like, share and subscribe.